A firewall is software that protects the system from unwanted network connections. In Ubuntu Linux, we can enable the firewall and manage it easily with UFW, which stands for Uncomplicated Firewall. UFW manages rules for the IP table packet filtering software and make it somewhat easier to manage them than if you had to deal with them directly. By default, UFW block any incoming traffic that is not associated with outgoing request. So in order to not cut off our own access here, we will need to add a rule allow it our access. SSH uses port 22 and the TCP protocol, so to create a rule I will write UFW allow 22/TCP that lets traffic intended for port 22 through the firewall, so it can be used by the SSH server. When you start up a service that uses a port on your server, you will need to open up the port on the firewall. If you want other system to be able to connect to it, with our one rule in place, let's start up the firewall. I will write UWF enable to start up, and I can take a look at the rules with UFW status. Here's the rule for port 22 on both IPv4 and IPv6. As you can see on the screen, we can add other rules. Let's say we have a web server running on the system on port 443. To allow access there, I did write UFW allow 443 and then put a slash and a protocol. If I wanted to restrict traffic to TCP or UDP, and running UFW status again shows that the rule been added. In many cases, a service you might run on the server will only need one port to be accessible from the outside, but some services need more than one port. UFW is aware of some services that installed packages use, and you can use that to set up ports as well. You can see what apps UFW knows about with UFW app list, and then you can use the name there in your allow or deny rule. You can also add ports by common service name, which are found in a list of common services and their ports at etc services. In addition to just allow or deny access to everyone on a particular port, you can also make more complex rules that allow access from certain host or network or only to a particular interface and more. While controlling the firewall is useful, I want to take a moment to show you a few other things that will be useful as you were working with the firewall. First, we can use the SS tool to see what ports are open locally. These are not firewall ports, they are services running behind the firewall that are listening on local ports. So for example, we could have a web server running and it would be listening for traffic on say port 80. But if the firewall blocked port 80, we could still access that web server locally from the same computer that it's running on. That's what SS shows us, and we can use it to make sure that services are in fact running and listening as we expected. I will run command here with the little string of options that I intend to use -ANPT. The A option shows all sockets, ones that are listening for input and also those that are connected. The N option shows numeric ports. The SS tool tries to figure out the name of the service running on a particular port. Usually it's right. It uses that list that etc services to look up a number and associated a service name. But occasionally, if you are running something on a non-standard port, it will get it wrong, and because we generally configure things by port number rather than name. The -n option is useful because it shows us the actual port number. The P option tries to figure out which process is in the change of a given socket, which can be useful if you need to work with the service and manipulate the process. This option is more useful if you are using super user privileges because you are able to see processes running as other user like web server, database server, and pretty much any other systems level service. Otherwise, you will see your own user processes, and that T option shows TCP sockets in addition to other. In many cases, when we are working with web server, database server, service like SSH, we will be using the TCP protocol. Some other services use UDP, and you can use the -U option to show those. Be sure to look at the manual page for SS for more information. Here in the output of command, I can see the connection that are active and what's listening. Not anything too interesting right now because there's not a lot of running processes. Here I can see port 22 is listening on my server IP address, and that it connected to my client. The process in charge of that is SSHD. These are the sockets that are listening locally. We can take a look at the firewall rules we define to see what's active there, and then from another system we can use a tool called Nmap to see what ports are open from the outside. Nmap is a useful tool for scanning networks, and because of this it's helpful troubleshooting tool for a remote server. Nmap can also be used for fairly aggressive scan, so be sure you are responsible when you are using it. I will disconnect from my server and use my client system here. I will install Nmap with apid space install space Nmap, and then if I run it without anything else, I can see a quick listing of things I can do with it. As I mentioned, there's a lot you can do around scanning network, but let's just explore our server. To do that, over at nmap space -s small s capital and the IP address of the server. After a few seconds or little time, we will see list of what ports are open on the firewall from the system perspective. Here I can see that 22 is open and SSH is running there, and I can see also port 443 is open, but the state says closed. In this case, this port is open on our firewall, but there's nothing running on the server to respond to that port. As we can see on the output of SS command, with these tools you can troubleshoot most issues around remote access. Check that your service is listing locally, make sure your firewall accommodates the service, and then make sure a remote system can access it the way you intend. And be sure to take a look at the firewall log to see what actions it's taking.